Hello everyone, I am Sowmya, and I would like to start with you guys imagining a world where AI is not actually following any instructions, and it acts like a team of personal assistants, and it is autonomously trying to solve issues and problems for people. Um, so, how many of you guys have worked in AI frameworks like LangChain, Llama Index? Cool, cool. So I see a bunch of you guys. Uh, what we'll do is we'll explore how to build such intelligent agents using two very powerful tools, which are LangGraph and DSPy. Now these tools, let us go beyond one of prompts or a simple chatbot, and it gives us a structured and modular system that can reason, act, and adapt. So all these intelligent systems are actually transforming our industry. In fact, we have developed and in fact deployed in production one of the such systems, which is a real world evidence explorer, which looks into patient data, diagnosis, and all this kind of data, and it helps clinical researchers to get better understanding of that information. Uh, so that is based out of DSP and LinkedIn as well. So yeah, a lot of real world use cases on that. Apart from that, it also helps in customer support automation or supply chain automation, those kind of things as well. Now, to sort of give a brief of what we'll do. Um, so first we'll start from the basic, just for people who don't who are not very acquainted with that, and then we'll do a deep dive into a little bit of agentic sort of a solutioning and what agents really do or why they are called agentic, and then we'll go finally into one of the demos where I'll show a simple financial analysis tool, which is based on this LangGraph and DSPy, and show that how these two are working together to give a better solutioning, to intelligent solutioning. So agents are like personal assistants that make decision autonomously. So what does it really do that makes it really agentic? Now, starting from the building blocks, every GenAI solution is made up of three primary elements, which is like tools, functions, and agents. Now, tools, I would say, are external capabilities which we give to LLM, and functions are the bridge between the LLM and the tool calling. Now, combined these two and memory and the feedback, you get an agent which can reason and take actions autonomously. Now, for an example here, you can see that there is an agent, and it is actually leveraging both internal functions as well as external resources to get its understanding, reasoning, and sort of objective which it would have. Now, what is really an agentic solution? So it makes decision autonomously. But how is that? Because it understands the user's goal and plans according to that action, executes based on that, and gets a feedback, and from that feedback it is trying to improve itself as well. So agentic systems by itself are modular, and they scale because the more agents you add, the more powerful it becomes, because its scale increases. It can range into different domains as well, and it can interoperate with different agents or different APIs. So I would say that an agentic framework for me should have at least these four parameters, which is like autonomy and goal orientation, which is like it knows that it has a goal and it is only working on that. It is not going anywhere haywire. Okay, and modular by itself, adaptable in terms that if there is some new data or new environment, it is able to learn from it and it is able to accommodate that as well, and scalable in terms that it can be extended into different domains as well as different kind of data. Now, what do you mean by closed loop operation? So it means that it sort of, I would say, starts a flow in terms of it gets the query, it tries to understand what it needs to do, it executes it, it learns it, and this flow goes on. So this is a closed loop, okay? And what makes these systems truly agentic? So at least it should be autonomous enough to take a multi-step execution, which is not relying on any human interaction in between. It should have the ability to improve, and it should be able to take meaningful actions without human in the loop. Now, if we come into multi-agent systems, so multi-agent systems are the systems where multiple specialized agents, which are, you can say expert in their domain, are coordinating between themselves for a collective goal. Now, these are mostly used where there is a complex and a distributed task. So it's not a simple task, and you need expertise of various domains to actually be able to do it. Now let's say someone is retrieving the data, some other tool is filtering and extracting relevant information out of it, and some other tool is summarizing that. So in short, I would say they cooperate, compete, as well as coordinate between themselves to get a better response. Now there are different kind of structures in, I would say, multi-agent systems. uh, so starting with a centralized system. So centralized system is the one where there is supervisor, there is a single supervisor, and it is coordinating with everything from the planning till, where it is also taking care of hands on and hands off between different agents which are under it. So if you see here, this is sort of the architecture of a centralized sort of a system. Now second would be the decentralized system, which is the complete opposite of it. Now there is no leader there, and they just are communicating between a group of different agents, and are trying to negotiate and get a response, or get a hands on and hands off between themselves. But what do I mean by hands on and hands off is that they are passing that action between each and different agents. Now the third one is a hierarchical. Now this comes uh, in terms like this is almost like a centralized, but it is not completely centralized. Now this it has certain, I would say, maybe I can also show you here, sub supervisor agents, which are actually working to get certain logical reasoning. Like you make certain logical groups of agents which are working on a certain particular kind of task, and there is a sub supervisor which is handling all that for the particular logic. So that kind of a architecture is called hierarchical architecture. Now what we will be looking into today is the graph based architecture. Now what is really interesting about it? Now this is not really centralized, not even decentralized. It comes in between. So you can have a straightforward flow where you can have a straightforward flow where there is a straight line, like there is no deviation. But you can also have a dynamic interaction where if there are certain clauses, it can go into certain different area and operate around there. Now this is a decentralized system, but there is no control here. So in a graph based system, we'll have control over here as well. So we will be looking into this graph based designs in our LangGraph in a few while. Now let us come into LangGraph. So what does LangGraph really do? Why is it really so powerful? Because it extends out of LangChain, and we know LangChain by itself has a lot of integration with different tools and I would say models, etc. So it helps us build a directed graph of nodes. I mean, just to show an example here. So each of these are different nodes, and each node is actually an agent or a tool. Okay, and they are operating between themselves. If you see here, as I was saying, that in the decentralized system there is no control, but here we can control what task goes where, and we are trying to make sure that whatever our objective is, accordingly we are operating. Now Why? Another factor which really helps here is that we are able to see after every step what is the state or what is the output after every state, and we can stop the process in that particular step as well, and get our understanding that okay, is something going wrong. We can debug at each and every step. So that is the additional benefit you get when you use LangGraph in place of other kind of tools where there is straightforward flow, maybe a llama index or a langchain. Okay, so this is particularly intelligent, and I would say useful for flows where there are branches, loops, or you require memory. Okay, and you can pause execution wherever you require, and you can reroute paths dynamically if you have certain clauses in your workflow. So now let us talk a little bit about DSPy. I don't know how many of you people have heard about it. Can I have a okay, very few. So DSPy is, I would say, I mean, one of the very few frameworks which is really declarative. Like you are not really going into prompt engineering. You are actually trying to program your way through it. And what it really helps is that even if you have written a not very good sort of prompt engineering or a prompt for your agent, you have the ability to actually, I would say, optimize it, and optimize in terms that, so there are certain modules within DSPI which if you pass certain data set with your input and expected output and your prompt, it will try out different kind of scenarios and get the best prompt which will work for this particular scenario for your use case. Now that is a very strong feature to have, because you are not manually looking into the prompt, and you are not manually getting there that what should be my perfect prompt. It is doing it by itself. You just need to pass it. I'll show that as well in some time. Now, second thing is that it is very modular in terms that you can actually create just pick and drop multiple different kind of modules. You can just integrate them very quickly as well, and you will get a very sort of a solution which you can extend to like unlimited extent. Like the framework is like that. So in terms of optimization, I would say there are two particular optimization. One is like the automatic prompt optimization, which is a framework or algorithm called MiPro version 2. Um, and there is weight optimization as well. So let's say you have a language model, and there are sort of modules within DSPy that can actually, um, I would say, sort of modify the weights of that language model so that it works better for your use case, and you can actually save that language model for later use. And then there is module tuning. So here what you are really doing is you are passing around certain examples, which is like bootstrap few short examples or bootstrap fine tune examples with a random search. So all these examples, now when we pass examples in our LangChain or Llama index agents, what it really does is it just passes the examples. There is nothing else. But here, what it is trying to do is it is trying to see what examples work for this case. I'll show that as well. But for these examples, it also stores the reasoning. Like how did it reach the point where it was able to answer correctly for that particular example? So that reasoning helps the LLM to understand that okay, I need to follow a certain chain of thoughts to reach there. So this helps, to sort of optimize your modules accordingly. Now, just to showcase sort of how it works. Let's say you have a task. Okay, you have a complex task. Now you want to break that down into different segments. Uh, let's say you have so you define a task. How do you define a task? There are certain modules called signatures. Yeah. Can you see this? So signature is the primary fundamental, primary part of every DSPI framework. And there you can define your prompt as well as your input field and output field and the format in which you want to get that. No, it makes it really easy because you are not relying on, any Pydantic structure or any other kind of structure to get the proper prompt output in a format which you would expect. Now it has its own internal assertion reasoning as well. If there is certain thing is getting wrong, it will try to regenerate by itself. You don't have to give, like, this is happening in the back end. You are not really looking into all this. You will directly get an output out of it. Now a couple of signatures will work together to make a module. Now you can probably like imagine this, like signature is kind of a tool and module is an agent, which is a combination of multiple tools, and it is working for a certain purpose. Now as you see here, there is an optimizer. I was talking about me pro, and there is another kind of prompt optimizer is copro. But this bootstrap fusion and leveled few shot, these modules are for module optimization, which is like your agent optimization. It is not about prompt optimization. So there are different segments. Like, one is your weight optimization, which is for language model. One is your prompt optimization, which is for a particular agent, for a particular tool, I would say. And then there is module optimization, which is for a particular agent. So it is operating at three different levels as well for optimization. Okay, now it's time to sort of demo. Okay, I think it is visible, right? Yeah. So let's say there is a user query. Okay, before even going there, what is this? This is actually a financial analysis tool where all this flow is a LangGraph flow. Okay, all this one is one node from the LangGraph. I was not able to get the direct output out of LangGraph's flow workflow, but this is what is working in the backend. Now all this, while being a like LangGraph flow node, it is also one module of DSPy. Now what we have done here is that we are using LangGraph for orchestration, whereas we are using DSPy for our agents optimization. Now how does it work? So let's say we have a financial analysis tool. So what does it really need? It need certain agents which can understand financial data. They can go to do a web search if required and get certain information and extract relevant data out of it. So first, what we are doing, we are checking what kind of query is this. Is it a relevant query for us? Is it a financial related query, or is it a query like what is the weather today? So if it is a weather today, then it will not reply anything, or it will not even go into the intent. So what is really intent? Intent is like what all parameters are fitting for it. Now I have three different modules and three different kind of use case. First is it is very much focused on the stock data. Okay. Second is it is looking into the finance fundamentals of a certain company, let's say. And third is what associated news for that particular company we are getting out of web search. Now, all this is web search based modules. I wanted to keep it simple because otherwise, if you go into different modules, it will become very complex. And so, yeah. So now all these different modules have access to search. One is text search, which is like your, I would say, normal search, and then there is a news search, which will only look into the news sort of information out of your web search. Okay, and all this information is getting browsed through a Selenium sort of, I would say, artifact, and then whatever we get out of it, we are extracting relevant information for that particular module. Now, to sort of tell you the flow, how it will work. You have a query. Let's say you are asking, what is the is Apple a good company to invest in? Okay, this is your question. Now in query analyzer, it has three options. Is it a stock related question? Is it a company fundamental question? Or is it a news question? It can take any combination of three as well. So the query analyzer, its primary role is that it gets a list of combination of intent for a particular question. Now this gets stored in intent. Now, because it is a straightforward flow, there is no dynamic interaction here. First, it will go into the stock if there is a stock requirement, and based on that, it will do a web search and get required information, which is mostly into the text search. Similarly for fundamental as well. And then the news, if news is part of it, otherwise it will just go into the combined result and find a response for you. I can show you that. So just to show like what is my query for this particular case. So I have asked, is Apple a good investment? Okay, let's see what kind of responses we get. Just a heads up, I have used DSPy and LangGraph together in a lot of production environments, and good models like Claude, Sonnet 3.5, 3.7, and GPT 4.0, those kind of stuff. Um, but uh, but whenever I go into open source models, they don't really work. So I have to get some kind of workaround for that. Uh, so in this case, in the query analyzer, while I have given a sort of query that it should only response in terms of three keywords. Is it news? Is it fundamentals? Or is it stock data? But it still gives me, a complete sentence. So I have to parse required keywords out of it. So this is a workaround, but when you use better models, it will work out just fine. So if you see here, what it is really doing is now it is so I have asked it to only look into first three web search out of your application. So it is now looking at the web search, and eventually it will start to analyze that. So if you see here, it has analyzed it, and okay, if you see here, so the current stock of Apple is this thing, which is 0.55% increase. So yeah, it basically is trying to do each and everything serially. So first is the uh, stock data, and then it will go into the fundamental data as well. Now it is looking into the company fundamental data. Okay, now it has combined all the data and it has generated answer. If you see here, this is the answer. The answer is that current stock price is good, and it is a buy rating for many of the companies or the analysts. So basically, we are able to get a response out of it. Now, what is really happening here? This is a straightforward flow. We are not really, leveraging any kind of intelligence here. Now, how can we introduce a little bit of intelligence? Uh, so for that, let us go back to the drawing board. Now, the second flow is where we have separated out our query analyzer, and now we have a planner. What it really does is it. So now there is no straightforward workflow for a LangGraph. It needs to be created dynamically on the go. So first it analyzes the question, it gets what intent it shows for that particular question out of all these three modules which you already have, and accordingly it will create a flow and orchestrate the sequence of it. Now based on that sequence, we'll go and we'll create a LangGraph workflow out of it, and then we'll operate out of that. So, I mean, like we now are operating out of intelligence. There is nothing hard coded. It is just looking at the plan, whatever plan it is getting. Based on that plan, it is generating a LangGraph workflow. It is using its agents, whatever it is required, and then it is generating output. So we can see that as well. Let me just go. So that is this flow 4, where we have done all that. So in the meanwhile, I'll show you how does the structure of DSPy look. Okay. So this is a DSPy, typical DSPy module, you can say. Now, what does it involve? Ideally, this is a signature. This is a shortcut way of defining a signature where this is your input, this is your output. You can just do an arrow mark, and it will be able to understand. Okay, this is my input, this is my output, and this is the prompt, and you are just defining it like this. This is very simple, but when you go into more complex use cases where you require a chain of thoughts or a tree of thoughts, you need to give proper input and output fields. I wish I have that example, but let's see. So in this case, somehow it is not able to do a web search, but it is trying to look for certain way out of it. Okay, let it continue. We'll see that later. Now, if you see here, the LangGraph flow happens dynamically. So we are not defining any kind of node. We are just checking in if the plan has these keywords. Based on that keywords, it will go around and look for what node to pick up for that particular workflow, and it will create that exact workflow for that particular question. Now for here, the question was what is the Apple's current P ratio? Let's see what response it has generated. Okay, it is still trying to parse different stuff. So yeah, I mean, in terms of how this works, now we see that okay, there is some kind of intelligence which we have generated, but how can you make it better? Now we have all these modules. We can actually optimize them using DSPy. Okay, but these are simple modules. We are just doing predict. We are not doing chain of thoughts or any kind of stuff. So let us, I'll show you one use case where uh, tried certain things, which was like some examples out of it to show you how the optimization actually works. Okay, so I have shown two kind of optimization. First is module optimization, and second is like prompt optimization. Now, so I'm using Grok's models. These are like free models which you can use through a free API which you can get from their website. I have so all this is part of Light LLM framework. So they have their internal sort of tool calling, etc. And now I'm configuring the language model here. Now the module which is getting used from DSPy is teleprompt, and we are looking at Bootstrap FewShot. So we will be taking a few examples randomly out of a data set, and then we'll be sort of optimizing our module. Now I used LLM to sort of generate a train set because this kind of data it is difficult to get, and I just wanted to show you guys that how it really works. Now, if you see here, this is a typical signature out of DSPy. You see, this is the prompt, this is the input field, this is the output field. This is how you generally. This is a very simple prompt, but in use cases I've worked on where you are generating a SQL, which is connected to a database, and it has certain schema limitations which you can't use, and all that information you need a chain of thoughts. It will not work very well directly. So as I said, this is signature. Now I was talking right. Multiple signatures can make a module. Now this is a module, okay, where you are invoking that particular signature, okay, and you are invoking it as a part of chain of thoughts. So now it will think step by step rather than going directly in our previous methods where it was just a predict. So now we need to define a metric. Like how will you know that is it correct or not? You need to have a metric. So there are certain built-in metrics as well which are simple, but for a use case which will be complex, you need to build your own metric. So I have worked on this, and we have built like LLM as a judge modules which will take up certain information, and based on that it will reply if it is a correct or not, and accordingly that information will get feed into these optimizer modules, and it will help us compile our optimized module. Now to do we have time? We have time, right? Okay. Yeah. So I'll just quickly wrap up this. So if you see here, what we are trying to do is we are trying to compile. So compile is the function for it, and this is our signature. This is our module, and we have our data train set whichever we had passed earlier, like the LLM based training set and development set or test set, you can say. And these are our config parameters. So we are saying that we have 4 level demos, and we will be bootstrapping everything. Number of candidates, as in like number of iteration, will be 8, and it will take 4 threads. Now, if you see here, what it is trying to do is it is randomly picking up examples from our training set, and it is attempting to bootstrap and see if it can get correct examples which it is able to reply correctly. And if it is getting, it will be storing those examples. I'll show you how that gets stored, but eventually you'll see that it has bootstrapped certain examples. So it is also checking what is the best score. So as I said, right, there are 8 candidate programs. So it will check 8 times if what is the best output it can get out of it. And so 11 candidate programs were found. Now, what will really happen is, if you see here, we have done a compile cot.save. Now, what it does is that it saves the module. How does it save it? You can see it here. Now, if you see it, this is your signature which you had passed. This is the format of the signature in JSON. It also stores some metadata. And then in these fields, you will see that it has your demos. Now, what is part of demos is that, let me show you. Now, see here. It also stores the reasoning along with the answer and what rationale it followed. Now, how does it help is that whenever you are again loading this module and you will be calling certain questions which you want to be optimizedly answered, it will look into this reasoning and these rationales, and it will follow the same train of thoughts. And that's how you get more consistency when you are trying to generate certain answers. So it will reduce your hallucination, it will use less amount of tokens as well, and it will get a more a more consistent and more accurate answer. So this is how a DSPy works. The example I showed, this is a part of the prompt optimization. Let me just show you quickly how is that. So this is prompt optimization, same kind of stuff. Just what I want to show you is that how the prompt is changed. So this was the prompt we gave. Okay. So after optimization, I'll show you the prompt is stored is this one. Have a look. How is it completely different from what we shared? So it is able to understand that okay, we are dealing with financial data, although we were just telling it to just it's a normal data. It tried to make up a certain prompt which is working better in this kind of scenarios, and it completely modified the prompt which will give it better responses. So this is how DSPy is helpful. Now coming back to our slide. So in short, what I can say is that LangGraph gives us orchestration, which is like what to do and when to do, and DSPy gives us optimization, is like how to do it better, or I would say best. So together we get a workflow which is uh, like every LLM interaction is optimized, and your whole system is modular in terms that you can pick up any module, you can just attach it to the whole chain, and you will be able to debug it, and it is actually production ready, because you are not getting the hallucinations where you get when you just pass a certain prompt you to a direct LLM or even a direct RAG system. It can also optimize your RAG modules as well. So this is what I wanted to showcase, because it is a very good combination, and people should try using it and see how it goes for you. Thank you.